Okay. Right, so in question 1, we have this angle which is given as 49. So this is your angle at circumference. And this angle is your angle at center. So angle at center. So remember the rule, angle at center is 2 times angle at circumference. So if you want this angle X, we need to multiply this angle by 2. So 2 times 49 is going to be 98 degrees. So that's your angle X. So in this question, we want to find angle X. And what I notice is I've got a quadrilateral here. You see this quadrilateral? So I can calculate X directly from the 60 because I know the sum of my opposite angles in a quadrilateral, a cyclic quadrilateral, will equal 180. So I could say 60 plus X is 180. So this is angles in opposite segments, that rule there. So X then is going to be 180 minus 60. So your angle that's required is 120. Right, so in question 3, we got these crossing lines. So we've got a couple of chords that cross over it, and there's actually 4 chords, aren't they? 1, 2, 3, 4. So from this picture, I would say that I can call this angle here 24, because these angles are equal. So this angle is angle 24 because angles in the same segment. So that's the name of your rule. So this is 24 and this angle's 31. So we can calculate X, can't we? So we'll have X plus 31 plus 24. And the sum of angles in the triangle is 180. So X plus 55 is 180. So you're going to get X equals 125. So that will be your answer for X, 125 degrees. So in question 4, we can use the angles in alternate segments rule. So angles in alternate segments. So this rule states that this external angle will be equal to the internal opposite angle. So basically X is 77 here. So it's very useful to remember when you have a circle, a tangent line, it must be a tangent, and any triangle like that, that this angle out here will be equal to this one. And this angle here will be equal to this one. Very useful property to remember. That will save you a lot of work when you're trying to calculate this angle. So in question 5, we have an angle at the circumference. So this is angle at circumference, which is 54. And this is your angle at the center. So we know that 2 times angle at circumference will equal the angle at center. So 2 times 54 will be equal to X. So therefore X is going to be 108 degrees. Right, so in question 6 here, we have what looks to be a diameter line, which is implying that this angle down here is 90 degrees. Okay, so our rule to tell us this is 90 is angles in a semicircle. So when you have a diameter line, this line and this line, these two chords will form a 90-degree angle here. And we remember that this angle is 180. So using the same rule as in question 5, this angle must be half of this angle. So it makes sense that this would be 90. So from that, we can calculate x. So x plus 23 plus 90 will equal 180. So that's sum of angles in a triangle. So the sum is equal to 180. Therefore, x is going to be 67 degrees when you calculate x here. So x is 67. Right, so in this question, we've got, in the figure, we've got 2 times the length px is equal to length PA. So we could add the line PA on here, because, and also we note that PA and PB is the radius of the circle. So what I'm going to do here, I'm going to let PX equal the length X. So this is going to be, I'm going to call this X, so 2X PA. So that means that PA is equal to 2X. Okay, so X is PX. 2 times X will be equal to PA. So this is 2X. But we know that this length is also 2X. And the next bit, it says that AB is equal to 16 root 3. So this length here is 16 root 3. But we can assume that this is a right angle. It doesn't show that, but we'll assume this is the right angle. So we can do the question. So that means that half of that will be 8 root 3. So this length here is 8 root 3. So now you see we have a triangle here. We can use Pythagoras to calculate x. So let's make an equation. We'll have x squared plus 8 root 3 squared will be equal to 2x squared. Okay, just using Pythagoras's theorem. So here you're going to have x squared plus 8 eighths is 64, root 3 squared is 3, and this will be equal to 4x squared when you expand the bracket. So 3 times 64 is 192. So x squared plus 192 is equal to 4x squared. So that means that when we bring the x squared across, we'll have 3x squared is 192. And when you divide by 3, you're going to get x squared equals 64. And then taking the square root of 64, x will be equal to 8. So we know that x equals 8. And we want the length of PA. We want PA, which is the same as PB. So if x is 8, the length you want is 2x. So we've got 2 times 8, which will be 16. So your correct selection should be number 2, 16. So in question 2, we have a figure which is BD being 13. So BD is 13. So let's put that down. And AD is 5. Okay, so this is 5. And we notice that ST is a tangent at A. And you've got a diameter which passes through P here. So we know that the radius at this point will be a 90-degree angle to the tangent. So then we can basically use our Pythagoras to get the length PB. So let's do that. Let's call this X. So let's use Pythagoras. We're going to have x squared plus the other leg, which is 5 squared, equals 13 squared. So x squared will be 13 squared minus 5 squared. So x will be the square root of this number. And we're going to end up with 12. That would be 144. We should write that first, if you like. So that would be 12. So this length here is 12, isn't it? This is your diameter. But remember, in the question, it only wants the length AP. So it's only going to want half of that length. So 12 divided by 2, which is the radius, which would be 6. So the correct selection here is 6. So in question, we got the figure where CY is A plus 3. So let's write that length as A plus 3. We have AX, which is 2A minus 1. And we know that AC is 23. So this total length is 23. And our properties of tangents tell us that CY and CX are equal lengths. So what I can just do is transfer the A plus 3 to this side. So you can see now that the sum of these two sections, AX and CX, will add up to be 23. So you'll have 2A minus 1 plus A plus 3 equals 23. So you got 3A, and 3 minus 1 is 2, is 23. So 3A will be equal to 23 minus 2. 3A equals 21. Divide both sides by 3. Therefore, A will be equal to 7. So your correct selection will be 3.